Okay.
Everybody. Thanks for attending. My name is Alessio Trevisan, and I am the Endurica product manager here at Soft. I work on offshore and construction department where I used to calculate special structures for that field of activity. During my career, I found some elastomers on my path, and well, I can remember like it was yesterday that uh, was a big challenge. So I'm very happy to introduce you Dr. Will Mars, that is a true expert of that field. Dr. Mars founded Endurica LLC in 2008 to give product developers a simple and accurate workflow for analyzing the durability of elastomer products. The firm's products and services are used by leading firms around the world to manage durability. And by the way, Dr. Mars has received several awards for his scientific contributions and innovation. He has more than 60 peer-reviewed publications, holds 4 patents in the area of elastomers durability, and is the past editor of 2 scientific journals. Today, we'll focus on the business strategies of winning on durability, which is also the title of this webinar. After his speech, there will be the possibility to make some questions to him. So, without further hesitation, I give the floor to Dr. Mars. Thank you, Dr. Mars, for your presentation.
Thanks for the kind introduction, Alessio, and it's really good to be here today. Um, uh, uh, you know, the topic I've got is really business strategies for winning on durability. Um, and if you're an engineer, I don't know if you whoever's listening, if you're an engineer or a manager of an engineer, but what I'll talk a little bit today about the technology, but not so much. Really, what I want to talk about is when you are, when you are looking at durability issues in a business, how do you value them, and how do you, justify the efforts that are required to manage them. So that's really want to hopefully give you some new ideas on how to talk with talk with management about and with your customers about the value that's in durability. There's a couple of uh, little things I like to say. Uh, One is if you don't have durability, you don't have a product, right? Most of the rubber products that are out there on the market have a durability requirement, and, tires, bushings, mounts. That's related to the warranty on a car, or most rubber parts have a durability requirement, and if you can't meet that, you don't have a product. So durability is obviously a core value to the enterprises that we're engaged in. So and here's kind of uh, this is kind of a map of the things I'll talk the topics I'll hit today. Um, there's a lot of different ways that durability can impact a business. Um, there are impacts on there's impacts on the way that you go about uh, uh, winning new contracts. So if you're a plant that makes rubber parts, at some point somebody has to make an agreement to buy those parts, and usually people are in some kind of competitive situation, and so being able to be in control of durability and demonstrate that to your prospects is a great way to win new business. We could talk about the development process. I think when you talk about simulation software, a lot of times people focus a lot on the value that simulation brings in the development process. So that's obviously a very important one. We can talk about speed to market. We can talk about warranty. A new topic in the last few years has been digital twin. Um, People also these days are talking about material selection. In rubber, that's really important because, unlike steel or glass, which are largely, let's say, you know, commodity materials. Rubber is very much you know, it's much more like a French pastry or a birthday cake. Um, the material properties you get are very dependent on the ingredients and the chemistry and the you know, so every rubber compound is its own custom material, and so there's a big materials technology component that's involved in rubber technology. There's a lot of work that goes around lightweighting and optimization, and of course, these days everybody likes to talk about sustainability, and so these are all areas where there's value that you know that we can bring to the table. And what I really want to talk about today is how do you put numbers to that, right? So by the end of today's talk, you're going to be in a position, hopefully, where you can go back to your business, and I'm going to show you some simple, let's say, valuation models that let you estimate, hey, here's what this is really worth to me personally, and you know, and my boss, and the enterprise that I'm engaged in. If you're interested in our technology, I would say, you know, we'll be back later this year. I think we've got a series of webinars scheduled here with EngineSoft, so we'll be talking technology later. But if you can't wait, you can go to our YouTube channel, and there's you know, technology demos there. Okay, just a short introduction to Endurica. I founded the company in 2008. We are now, I think that's 8 people. Actually, 9. We've got an intern these days, but uh, and we are 100% focused on simulation technology for elastomers and durability. Um, and that's a little bit about Endurica. Let's see, 3 of us are PhDs, and 6 of us are engineers. So that's just a little bit about Endurica. Um, as far as you know, again, just introduction to Endurica, but our rubber parts, or our simulation software, is used to design rubber parts across many sectors. We're in the energy sector, the automotive sector, um, marine, medical devices, rail, aero. Those are all sectors where, again, you know, if you've got a rubber part that has a durability requirement, then that's where people are using our stuff. In fact, um, uh, every year Rubber News puts out a list of the top, you know, 100 or however many rubber companies in the world, and they rank them. We go through that list every year and we count how many of those folks are using our software. Last year it was 13 in the top 20. So in the last 16 years, we've really been able to help a lot of people. Here's kind of a, you know, a list of some of the companies that use Endurica tools. Um, so a high level, you know, what's durability worth? This is a quote that I heard from a guy who was working in the metal fatigue area, John Draper. I don't know if folks know him, but his claim was that the cost of failure each year globally is about 4% of GDP, right? Gross domestic product. And the opportunity we have with simulation is to cut that in half. So obviously 4% of GDP is a huge number. And being able to address that is really important. Um, Around the edges of the slide, you can see some of the more infamous rubber fatigue failures that have happened out there. Um, in the upper left, there's a picture of a tire. That was the Ford Firestone tire failures from the early 2000s. There's a rail accident that was caused by a failure of a rubber, a special rubber tire wheel for rail, that when it failed led to a train disaster. We think of the Dow Corning breast implant failures from the mid 90s. These are all, you know, examples of times when durability didn't work out right, and led to huge economic losses. So so here's kind of a quick approach, you know, agenda to how we'll approach this. First of all, I want to talk about the like I said, I'll just do a brief introduction to technology and not only the technology, but uh, Endurica's approach to um, bringing this technology. So, the words I've used are accurate, complete, scalable. That's kind of our mantra for the Endurica tool set. We'll talk about the kinds of materials testing we can do, the kind of software. You should really think of Endurica more as a toolbox than a single, than a single workflow or a single uh, piece of software. It's more a collection of things. But the workflows that we provide, like I say, we're really aiming to give you tools that are very accurate. They've got the right material models. They've got the right algorithms for doing damage analysis. They've got the right materials testing, and they're solutions that are easy to quickly deploy when you need them. Um, so, like I say, just briefly introduce the tools, and then, but the meat of this talk is all about the impacts on business model and how can we quantify that. Um, so first of all, let me say that there's in some ways you could sort of say that there are two major um, ways that durability simulation creates value. And if you think on the development side, everything is really aimed at how do I get the design right or the material selection right? Um, how do I get the engineering right on the first try, right? Development is sort of notoriously iterative. But the trouble with durability is that it's very time consuming and very expensive to evaluate, right? If you have to build a prototype and then put it out in the field to test it, that's always a very time consuming, very expensive um, thing to do. So we need ways to do the engineering such that the first time we go to take it out to the field, it needs to work the first time we do it. And that's what we're aiming at. On the other side, you can think about, and this is kind of a growing area, but there's a lot of application these days for simulation on the operations side. So, there's people who have some kind of asset, maybe it's a fleet of cars, or maybe it's an offshore platform. Maybe it's a critical seal somewhere in a, you know, in a, in a, in a complex system. Um, and there's a need for the people who own and operate those systems to have continuous monitoring of the structural health of those parts. And so the value proposition there is what we call real-time intelligence, right? And that's where people talk about digital twins and all of that. So the Endurica tools really kind of support both types of application. And and again, our mantra is, accurate, complete, scalable. So let's talk a little bit about, what we mean by accuracy. Um, and the with first of all, on the material behavior side, rubber is very different from metals. There's obviously codes out there for doing metal fatigue, but even at a molecular scale, rubber is very different from metals. The material behaviors are very different. The math you use to deal with finite straining is very different from, small strain analysis, linear analysis that you use for metals. So you really need, specialized tools for that. These are just some images of just a few of the types of things that we do. On the left, this is a crack growth rate curve that we've measured on some materials from Exxon Mobil. So they have a thermoplastic elastomer called Santoprene. Um, and we've got material models that can replicate, reproduce the kinds of crack growth behavior that their material has. In the middle, there's what's called a Hay diagram. It's a map of how the fatigue life depends on mean strain and strain amplitude. And that's for a project we did for the Army for one of their materials. But that basically, shows you the mean strain dependence of fatigue life for their materials. Um, and we have a testing service called Fatigue Property Mapping that lets you measure all of the different special effects that rubber exhibits. We have testing instruments. We partner with a German company, Coesfeld, for that. So people can, and we'll get to this when we talk about scalability, but we've got offerings for if people just want to do a little bit of testing, we can handle that. If you want to do a lot of testing, we've got solutions for that as well. Another component of the accuracy side of things is we use an algorithm called critical plane analysis. The idea in critical plane is that you assume that there's a crack everywhere in the part, and you evaluate every single possible crack that might exist in the part. And what's really powerful about critical plane is that it allows you to make accurate predictions when you have multi-axial loads, right? Multiple load input channels, loads that are load channels that are maybe out of phase, um, and accuracy when you have combined tension compression cycles. So when you have very complex loads, critical plane is the way to do it. Again, this is not a technical talk, so I'm not going to unpack that very much, but that's a really important technology that's kind of core to our tool set. Um, and then the last point I'll mention on the side of accuracy is that our tools also allow you to deal with the variable amplitude side of fatigue problems. So if you want to work with road loads, right, a recording from the track, say, or maybe results from a vehicle dynamic simulation, we can handle that. We've got damage accrual algorithms that allow you to to see where the damages come from, when it happens, so very, very powerful tools. These are in use by automotive OEMs to do their design work. So, like I said, excuse me, not going to focus too much on the technical side. So that was the accuracy. I mentioned accuracy, completeness, scalability. On the completeness side, I just want to mention that we've got three tools. One is called Endurica CL, one is called Endurica DT, and one is called EIE. CL is, you can think of that as kind of the core solver. DT is our incremental solver, and EIE is a tool that allows you to look at road loads. These three tools allow us to cover pretty much any type of fatigue analysis problem that you might encounter. So if you want to do infinite life analysis where you're just looking at a fatigue threshold and trying to stay below it, we can support that with the CL tool. If you're doing safe life analysis, where you're interested in looking at number of repeats of some load case or some schedule of load cases, we can do that with our CL and our DT tools. And if you're looking at a damage tolerant type of approach, we can support that as well, where you're actually tracking damage development through a series of load cases that's just always changing from moment to moment. And maybe you're looking at the evolution of residual strength or residual life in the part as you put more history on the part. So all of those are tasks that our tools can support. I mentioned, and this gets to the topic of completeness, right? We have a workflow for just about any type of durability problem that you can bring to us. We have materials testing for all of the different components of the physics in the rubber. We have a service called Fatigue Property Mapping, where people send us samples of rubber and we test them, and we give you back basically a material model that you can use with our code to do fatigue calculations. We also help people implement these test methods in their own labs if there's a high enough volume of testing to justify that. So, and then finally, the last point on this topic is that our solutions are scalable. So if you're doing zero fatigue life prediction, on day one, how can you very quickly scale up? So for example, people sometimes start with just using consulting services, right? So not even take a license of the software, just come to us with a project, and we can help you with that. We do have a materials database. So if you don't have the luxury of measuring the material properties for your material, we do have a database that maybe we could find something that maybe is like your material in some ways. Um, but what's really beautiful is there's a path towards, as the need and the validation case it gets strengthened, you can very quickly ramp up your adoption of the tools, and so maybe a brand new user might be using our infinite life and safe life analysis approaches, might be using just the basic testing to look at stress strain behavior and basic fatigue crack growth behavior. Um, um, you might start some validation projects on a component to gain confidence with the workflows. Um, at a more advanced level, you can talk about doing the damage tolerant types of analysis. You can start adding in some of the additional physics that happen in certain problems. And eventually you can even get so far as to doing analyses on full road loads um, using our tools. So again, just there's a path to basically bringing these tools to bear on on um, on these problems at pretty much any scale. Okay, so that's a quick introduction to Endurica, the company, and kind of the basket of tools that we bring. So let's switch tracks now and talk about excuse me, how these tools create value. One really, one way that these tools create value is they provide a competitive advantage to part suppliers who are seeking the business of OEMs. So typically, an OEM, a car maker will put out that they'll seek for bids on new business. They'll say, "Hey, I've got a new car program, and it's coming out in a year or two. I need to get 1 million bushings to put in these cars. Let's take this to 3 suppliers and shop it around and see who can give us the best package," right? Um, Obviously, pricing is important on that and other details, but in those packages, there is often a significant engineering component. And when people bid on these business packages, I think the timelines are often pretty short, um, but the OEMs really want some kind of uh, validation or evidence that the design that's being proposed uh, is going to be adequately durable under the intended use. And they also want to know that the supplier has the expertise and the capacity that if an issue arises after the contract is put down, that they'll be able to address the issue and make sure that durability doesn't become, a warranty problem for the auto supplier. So the way you can, let's say, put a value on this is you can say, hey, look, um, think about how many suppliers the OEM lets the contract shops this around to, and let's just say, for the sake of argument, that the contract value is $1 million. Um, the way you can estimate the advantage, it's you should think of this as a winner takes all game. So um, you know we let this out to, we get bids from three suppliers, and all of those suppliers have a plant, they all have a capacity to make parts. um, so the OEM is going to pick the one that seems like they have the competitive advantage, and of course durability is a strong way to show advantage. And um, so if you think that on average, if nobody has an advantage, you could say that on average, if you have 3 suppliers, I'll win 30% of the time, and the other 2 guys will win 30% of the time each. So that would be sort of like an average if there's no advantage. If you have an advantage, then you win 100% of the time. And so the difference between winning and not winning, um, you know, if you take that $1 million and you multiply it by that probability, n minus one over n, where n is the number of suppliers. So you could argue that half the value of that $1 million contract, if you've got two suppliers, half the value of that contract comes from having the durability advantage. If they're bidding it out to three, it's even more, right? The larger the competition, the greater the value of the competitive advantage. So anyhow, like I say, just a simple model that you can use to put a number on what this is really worth to you. A lot of, and I'll just mention that a lot of the suppliers these days are pushing very hard to get people to show what they can do with simulation. Again, it has a lot of value in the new business phase. This is a slide just showing kind of the transition that we're living in right now. Some of the OEMs here in the States have given talks in conferences where they're talking about trying to really highly ramp up the virtual side just in the next 2 or 3 years. Um, and again, it's all about engineering first, right? These are some quotes that we've heard at conferences from a few folks at GM, basically saying that by 2025 they want to be 100% virtual in their development programs. And that's obviously a very aggressive goal, um, but they are holding um, suppliers accountable to that. Um, so let's talk about another way to think about value in these problems. And this kind of is more related to the development process. So when you go to develop a new rubber part, um, there's a certain set of different types of efforts. And you could think of a budget of how much effort goes into, selecting the material, um, specifying all of the manufacturing details of the product, um, doing analysis to make sure that it, fitness for loads and so on, building a prototype, doing all of the product testing. You can lay out a budget, you can lay out a timeline. Having lived through this in a past life before I started Endurica, I think that it would be maybe typical to say, if you're doing product development, maybe that's a team of 5 people. Each of those people is paid something like, in round numbers, $100,000 a year. And maybe that team takes 6 months to go through one iteration, right? And so what this really implies is that, and this is not thinking about the external cost. This is just the people cost of running these iterations for product development. But if you get to the end of that 6 months and you run your durability test, right? The durability test is the last thing we do. You get to the end of that. If the product doesn't pass, you get to do another iteration, which means that, if you take 6 months of people, 6 months, 5 people, $100,000 a year, and you trash can that iteration, that's a $250,000 right there. Plus, you've just lost time to market. Um, again, the value in simulation here can be estimated by what it saves you in terms of decreased risk of having to do another expensive iteration. And so this, like I say, again, simple model for calculating what that might mean in your context. You change the numbers to what your situation is, but that's another way to think about it. uh, we could also talk about lightweighting, and that there's lots of ways to think about lightweighting. Of course, we've already talked about how to think about it in terms of competitive advantage, but you could also think of it in terms of a lot of rubber companies, actually do focus quite a bit on just how to take material out of a part, right? The material itself has a per pound or per kilogram cost. Um, and of course, if you take weight out of a car, you get better fuel economy. Um, and so, so this one's obviously very simple, but if you can take, if you can take, well, if you take 100, uh, if in your factory you have 100,000 pounds of rubber parts, and if it's a dollar, if you take a pound out, um, there's $100,000 right there. So you could think of this in terms of taking material out, and of course, when you're taking material out, the risk that you really have to manage is the risk that when you take material out, you increase stresses, durability gets smaller. And so these kinds of durability tools help you to navigate the uh, the lightweighting process. And the ideal is you want to take weight out without losing durability. Um, so if you know how much, if you know how much weight you're going to take out, you know how much material you're saving, you can calculate a contribution there. And of course, this is not even counting. I think usually if you make a lightweight part, that also has value to your customer. That's kind of not included in this kind of calculation. Um, but um, but anyhow, this is at least a conservative way to estimate. Now this for rubber, this is huge. This next one, um, material selection. Uh, so there's been studies done that show that when you have product failure in the rubber industry, about 40% of the time, or 45% of the time, I guess, in this study, uh, the reason for failure can be attributed to poor selection and poor specification of the material, right? So you have a rubber compound, you specify a rubber compound that's too soft or too hard or too, not enough carbon black, too much cross linking. Um, Poor material selection is just huge. Um, and it's not surprising that this happens. Rubber is a very complicated material, and in the lab, rubber labs tend to use a lot of very, let's say, simple tests that are, um, in some ways oversimplified. They don't reflect the true service conditions of the part, and so so like I say, getting these decisions right more frequently can have a big value. How do you estimate the value of that? Well, let's say you have 10 people, let's say you have 10 rubber compounders in your materials group. And again, you've got some salary for those guys. And let's say that you change I'll call it the hit rate, right? So let's say, before you start taking this kind of thing seriously, maybe you're getting the right material and the right application 50% of the time. Uh, if you can increase that from 50% to 2/3, um, there's a real economic value to that, right? And one way to estimate that value would be to just think of it in terms of if you think of the miss rate, um, as sort of trash can value, you can sort of do this simple calculation where you say, you know, 10 people's salary times the miss rate. There's some economic value there. Likely the value is going to be much greater than this, but this is at least a conservative way to kind of put some numbers on what it really means to do better in selecting the right materials for your application. Uh, Sustainable materials. Again, sustainability is a huge topic these days. Um, the trouble, one of the difficulties when you want to implement a sustainable material strategy is that it requires you to change out materials that work for materials that you don't know if they work. And anybody who's in development knows that most of the things that you try don't work. um, so, you know, um, So that's where these tools can really help is helping to sort the ones that will work. I saw an interesting study online when I was looking for ways to put numbers on these kinds of things, um, and I found one study that showed that about half of consumers are actually willing to pay more for a sustainable product. So, there's a pretty large group of people who would pay a little bit more, 25% more. And there's even a small group of people who would pay twice, right? 100% more if they felt that the product was sustainable. So there's definitely value in that, and the way simulation tools can help with that is, again, helping with the get it right the first time type of a tactic. Um, another um, let's say another way to think about this is to think about the impact on product delay. Whenever you have a product development program that gets stuck because of a durability issue, um, that generally translates into delays of the launch of the product, right? You can't, at least in the tire world where I came from, there's actually quite strict regulations, and if you don't pass the durability test, that tire can't go to the market. Um, and so if you're talking about publicly traded companies, you can look in the news, you can look at the stock price, and for a company that has a capitalization of $1 billion, if you look at what's the hit to shareholder value after they announce a product delay, I went and I did this exercise for, I don't know, maybe 5 companies, uh, and just using round numbers, it was not uncommon to see a hit to shareholder value of about 10%. And so you could take the view that that sort of represents the marketplace telling these companies that, hey, in that case, there's a value at stake here of 10% of $1 billion because of the product delay, right? That has to do with your certainly, if it affects your first mover advantage in business, that certainly that could justify this kind of thing. But again, just another model for thinking about what durability might be worth. Right? Again, if you don't have durability, you don't have a product. Uh, Another one I'll mention is what I call OEM warranty responsibility. Um, so a lot of part suppliers put their parts into a car, and the contracts that the part suppliers have with the OEM often have some kind of warranty provision where the um, the OEM will say, "Hey, look, if these parts come back from the field, there's some kind of economic adjustment. You're going to pay us for things that fail, right? Um, the OEM needs the supplier to be responsible for the quality end of things and for failure. So another model that you can build out very simply to look at the value of getting these things right is to look at what your warranty exposure is, right? I think most companies track the cost that they incur due to um, let's say returned parts, failed parts from the field. And so if you've got, let's say you had $10 million worth of parts out in the field, and if you know that 1% of those are gonna, and let's say that if you make the right decisions, you can reduce your adjustment rate by 1%. Well, 1% of 10 million bucks is that's a person's salary for a year. So it's worth it to pursue these kinds of initiatives that will help you to resolve these types of issues. Um, so yeah. Okay, so anyhow, so that's I think a pretty good list of hopefully I've given you some ideas on, when the boss says, well, why should I care? Hopefully I've given you some ways to sharpen your pencil and um and come back with some really sharp and incisive insights into how these things can benefit your business. And just I guess to summarize what we've said, you can look at things that are changes to the revenue side of the equation, right? So we talked about competitive advantage. We talked about cost avoidance on the development side. We talked about lightweighting and sustainability. We talked about avoiding product delays. We talked about dealing with warranty type failures. Um, we've talked about testing capacity in terms of, less iterations. Um, and yeah, take these models that we've given you and plug in your own numbers. I also just want to mention just some ideas of what I call fast tactics. So you get off this webinar and you think, that's all nice and theoretical and I can calculate a number, but what can I do at my company today that might start, okay, so I get a simulation tool. What do I do with it to immediately create some value where I am? And so this slide is just a few ideas on things that you might try to do. So one would be to obviously implement durability simulation as a part of your new business process, right? So whoever's writing the proposals for, to the OEMs for part contracts, you probably want to make sure that durability simulation is a part of that process. Being able to take the engineering package that you get and coming back a week later with, we know that this can pass and here's why, and here's your loads and here's our analysis, very valuable. And not so hard to implement these days. Um, uh, Another quick tactic that you could use is to do what I call a design audit of durability sensitivities on your existing product line. So no doubt that you have a bunch of existing products, and if you were to go and run simulations of just your, look at your current products, maybe the ones that have the worst durability issues, and kind of do an audit and do figure out, hey, what would be the sensitivity to durability if I changed out the material? What would be the sensitivity if I changed this radius or this thickness, right? And just look at your current product lineup, do the durability analysis on each of those products, figure out what the sensitivities are, and pretty soon you'll be in a position to um, make some real improvements there. I find that durability is often under optimized. What happens is, because durability is the most expensive and the most time consuming, what happens is as soon as people cross the line the first time, they say, "Oh, we're done," and they put the part into production, and you just live with whatever it is. But that leaves things under optimized, because if you don't, you know, the upside of going through lots of iterations is that you converge to a, let's say, a lighter weight solution, or a more optimized solution. And that's hard to do when you can only do one durability test per iteration. But when you have simulation tools, you can explore the design space much more completely. And for every physical prototype iteration, maybe you can do 100 or 1,000 virtual iterations. And so this idea of taking your current products and doing, I call it, like I say, design audit, it can be very valuable. Um, we could talk about new product design optimization initiatives. So, you might come in, and if you guys are working on a completely new product, you can use simulation tools to do optimization types of things. It's like, okay, I've got a design on the drawing board here. How do I make sure that it's optimized, right? And again, it goes back to being able to do many more iterations virtually. Um, and exploring the design space. Um, Another tactic that you can deploy is to uh, go to the people who track your warranty adjustments and say, "Hey, what's the top thing that's coming in? And can I solve that?" Um, Durability analysis, that'd be a very fruitful place to look for using a durability analysis. Um, Another tactic I would highly recommend, whether or not you use these tools, is you really ought to be tracking your material selection win rate, right? So somebody has a dashboard of KPIs, right, metrics that they watch on how the company is doing. One of those metrics should be how frequently you picked the right material for the application. Keep track of the wins and losses, and if you're going to start using these tools, you can watch how frequently. You should see that when you use these tools, you should get better decisions, and so you can measure that. Of course, you can offer simulation as a customer support or a customer service, and particularly in the we've had users of our tools who are on the raw materials business, right? Polymer suppliers, rubber chemicals, carbon black suppliers, who are using our tools as a customer support. So, um, maybe their customers don't have a simulation capability, but if you can do this for them, that's a value that you can add with these kinds of tools. You can also, if you're a material supplier, you can show people what your material looks like in their application using these tools. Um, Obviously, cost reduction initiatives are fertile ground. Um, Another one that we've sometimes seen is that we've seen people adopt a rule. This was in the tire sector, but somebody made a rule that we are not going to buy a new tire mold until somebody does the durability analysis to make sure there's no, groove cracking in the tire. Um, and if a tire mold costs you $100,000, um, these tools can have an immediate payback in terms of preventing, you know, doing a ton of machining on a mold that ultimately, creates a durability issue. Um, and I guess I sort of already mentioned simulation as a new material qualifier, so I won't belabor that. But yeah, these are just things you can do. If somebody says, how do I use this tool to do something that matters? Just some ideas. Okay, so that's kind of the meat of the presentation, and this, I guess, is just a summary of what we said already. So I'll stop here and open the floor up for any questions that may be out there. Um, I think so. If you have any questions, what I would ask is that you type them into the. Does the Q&A work on this? I see there's a Q&A option in the tool. So if there's any questions, if you just type them into the Q&A, or I guess the chat could work too, um, and we could go from there.